Hi everyone, I'm Celine and I'm the president of Lee BMES, which is Lee's Biomedical Engineering Club. So I'm just going to be giving a quick overview of what our club is all about. So just some basic information about our club. We have meetings every Friday from 12 p.m. to 1 p.m. and our website is leebmes.weebly.com. So, what exactly is LeeBMS? Well, like I said, LeeBMS stands for Biomedical Engineering Society, and we're actually the first ever high school chapter. And not only are we the first ever high school chapter, we're also the first ever high school chapter to be recognized on the national level. So we were the first high school chapter to win a national award, which we won last June. And we were granted the Treble Award, where we got this big grant, and we also got several registrations to this national research conference. So, what exactly is bioengineering? Well, bioengineering is the application of engineering principles to design solutions that meet clinical and biological need. So you're probably familiar with artificial organs. So what do you do when a patient needs an implant, but there are no donors who can give them that organ? Well, this is where bioengineering can play a humongous role. And so here's a picture of an artificial heart that researchers in Texas actually designed and created. Moreover, bioengineering is very interdisciplinary, so it draws from multiple fields like chemistry and computer science and biology. And so you might be familiar with this structure, maybe not, acetyl salicylic acid, more commonly known as aspirin. So, how can we use chemistry and bioengineering to design drugs that have as big of an impact as aspirin has had? And of course, you're probably familiar with orthotics and prosthetics, such as prosthetic feet. So ultimately, bioengineering is all about expanding the borders of human knowledge and using that to address biomedical issues such as cancer and asthma and Alzheimer's. So, what have we done in the past? Well, every month we focus on another concentration within bioengineering. So, for example, this month we're focusing on genetic engineering. In the past, we focused on stem cell engineering and neural engineering and computational biology. And at every meeting, you can expect mini lessons as a group. Sometimes we have group discussions. Just for example, just last week we had a group discussion on the bioethics involved in genetic engineering. And you can also expect guest speakers. And also, being one of the few high school chapters, we do a lot of collaboration with local BMES chapters. So we've collaborated with Stanford BMES and UC Berkeley BMES and SJSU BMES to bring guest speakers to you guys. So I'm just going to now go over three specific examples of what you can expect at any given club meeting. So here's an example of one that we did this past December, which was this bioengineering design challenge where our club members applied everything that they had learned that semester to design a bioengineering based solution. So here's an example of what one group proposed. So they said that if we can take stem cells from a patient, then we could differentiate them into kidney cells, and then using a 3D printer, we could assemble those cells into a 3D scaffold. And with that, you'd have a kidney that you could then transplant into someone who needs an organ. We've also done club meetings on computational chemistry. So in school, or in chemistry specifically, we're taught about VSEPR theory. But at LEAP-EMES, you learn that VSEPR is actually incorrect. So we taught our club members about density functional theory, which is an alternate way to represent these structures in 3D. And we had our club members use density functional theory to find the 3D geometry of monastrol, which is this super potent anti-cancer molecule. And then from there, they docked this anti-cancer molecule in its 3D form to the specific receptor within cells that it inhibits. And so they were able to find the binding affinity of how strongly this anti-cancer molecule interacts with the specific protein that it inhibits in cells. And one competition that we highly encourage our club members to participate in is BioEHSC, which is this UC Berkeley bioengineering competition where students work in teams along with a UC Berkeley undergraduate mentor to design a solution to address any medical issue of their choice. So here's an example of one that we submitted in the past, where we designed this injection that could be used to treat chronic tendinopathy, which is a very common athletic injury. So with that, I thank you for listening. In our club, we like to have a lot of fun. We're super encouraging, welcoming, and it's always a super fun environment. And once again, we meet every Friday from 12 p.m. to 1 p.m., so during your lunch break. And if you would like to get the Zoom link for that, you can either find it on our website, which is, like I said before, leebmes.weebly.com, or you can join our Remind chat where we send it every week. And to join that, you just text at leebmes to 81010. So I thank you for listening, and I hope that we see you at our next club meeting, which is going to be this coming Friday.